In the summer of 1956, 10 men gathered at a small college in New Hampshire to build a mine. They had written the proposal the summer before, and it opened with a sentence that would echo for the next 70 years.
We propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956.
Until that document, the phrase artificial intelligence did not exist. John McCarthy invented it for a grant application. He wanted a name that belonged to nobody. A clean word, free of the old arguments about cybernetics and machines that think. They asked the Rockefeller Foundation for $13,500. They were given $7,500. For that money, 10 men would spend 2 months on language, abstraction, and creativity. Problems the entire species had never solved. The proposal claimed a significant advance could be made if a carefully selected group of scientists worked on it together for a single summer. The summer ended. The problems did not. But something more durable than a solution was made that season, and it outlived every person in the room. A belief. The conviction that thinking machines were not a question of if, but only a question of when. That belief would raise fortunes, build entire industries out of nothing, and then bury them. Twice in the decades that followed, the field collapsed so completely that its own name became unsayable. This is the story of the AI winters. And it is the story of why the people who lived through them are nervous right now. On the 8th of July, 1958, the New York Times ran a short story on page 25.
The Navy revealed the embryo of an electronic computer today. That it expects will be able to walk, talk, see, write, reproduce itself and be conscious of its existence.
The machine behind that sentence was the perceptron, built by a psychologist named Frank Rosenblatt at Cornell. Strip away the language, and it was a single layer of artificial neurons that could learn to tell one simple shape from another. That was all it was. It could not walk. It could not talk. It was certainly not conscious of its existence. But the promise was intoxicating, and over the next decade the promises kept escalating. In 1965, Herbert Simon, a future Nobel laureate and one of the most careful thinkers alive, made a prediction.
Machines will be capable, within 20 years, of doing any work a man can do.
5 years later, Marvin Minsky told Life magazine something even bolder.
In from 3 to 8 years we will have a machine with the general intelligence of an average human being.
Minsky said that in 1970. Count forward 8 years, and you arrive at 1978. By 1978, the field he was describing had already been dismantled. Because in between those two sentences, 3 documents arrived, and each of them took money away. None of the 3 were written by enemies of artificial intelligence. That is exactly what made them fatal. The first blow landed in November 1966, and it was aimed at machine translation. A committee of scientists had spent 2 years on one question. Could a computer usefully translate Russian into English? By the committee's own accounting, the government had spent some $20 million over 10 years finding out.
There is no immediate or predictable prospect of useful machine translation.
Machine translation funding in the United States effectively ended that year. The field did not properly recover for 2 decades. 3 years later came a book. Marvin Minsky and Seymour Papert published Perceptrons in 1969. They proved, rigorously and correctly, that a single-layer perceptron could not learn even the simplest logical functions. What they actually wrote about deeper, multi-layered networks is the part that almost never survives the retelling.
We consider it to be an important research problem to elucidate, or reject, our intuitive judgment that the extension is sterile.
It was an open question, handed to the field as a challenge. The field heard a death sentence and walked away for 15 years. Then in 1972, the British Research Council asked a mathematician named James Lighthill for an honest assessment.
In no part of the field have the discoveries made so far produced the major impact that was then promised.
He blamed the combinatorial explosion. Every problem worth solving branched faster than any machine could ever search it. British funding was restructured around his verdict. Whole research groups lost their institutional home. The first winter had arrived. Winter's end. This one ended the way most things end in this industry. Somebody made money. In January 1980, A program called Xeon went to work in a digital equipment factory in Salem, New Hampshire. It did one narrow, boring, extremely valuable thing. It made sure that complicated computer orders were configured correctly. Estimates of what it saved the company run from $15 million all the way up to $40 million. It was not intelligent. It was a few thousand rules, handwritten by interviewing the people who already knew. But it worked, and industry noticed. They were called expert systems, and every large corporation wanted one. An entire hardware industry grew up to run them. Machines designed to do almost nothing except execute a programming language called Lisp. Japan announced its fifth-generation project in 1981, a plan to skip a whole generation of computing. Britain answered with ALVI. America answered with the Strategic Computing Initiative. Nobody wanted to be left behind. By 1985, corporate spending on artificial intelligence had passed $1 billion a year. And in 1984, at the field's own annual conference, two of its founders stood up and warned it. The panel was titled The Dark Ages of AI. Roger Schank and Marvin Minsky told the room the enthusiasm had outrun the results. They described what was coming as a chain reaction. Pessimism inside the field, then pessimism in the press, then the money leaving all at once. They were 3 years early. The collapse came in 1987, and it came from a direction nobody found glamorous. Ordinary desktop workstations, from Sun and others, got fast enough to run Lisp about as well as the specialized machines did. A Symbolics machine cost around $50,000 before you configured it. A general-purpose workstation cost a fraction of that. One historian summarized that year in a single line. An entire industry worth $500 million was replaced in 12 months. Symbolics revenue fell from about $100 million to $82 million to $56 million. Lisp Machines Incorporated went bankrupt outright. The companies that built the field's hardware never came back. The expert systems outlived the hardware, but they carried a quiet flaw that nobody could engineer around. Every rule had to be written by a human being, and every rule you added made the next rule harder to add safely. Xeon grew from 250 rules to more than 10,000. Keeping it correct became a full-time industry of its own. In Japan, the fifth-generation project ran to its scheduled end in June 1992. It had spent roughly 57 billion yen. Its specialized machines were overtaken by ordinary chips before the project even finished.
It ended not with a successful roar, but with a whimper.
And then something stranger happened than the funding drying up. The name itself became a professional liability. Researchers doing precisely the same work called it informatics, or machine learning, or knowledge-based systems. Anything except AI. A New York Times reporter described the low point more precisely than any historian has since.
At its low point, some computer scientists and software engineers avoided the term artificial intelligence, for fear of being viewed as wild-eyed dreamers.
That is what a winter actually is. Not the absence of work, but the absence of permission to name it. The research continued anyway, quietly, in the few places where nobody important was watching. Then in 2012, 3 researchers in Toronto entered an image recognition contest. Alex Krashevsky, Ilya Sutskever, and Jeffrey Hinton submitted a deep neural network called AlexNet. It was multi-layered, precisely the architecture that perceptrons had been misread as ruling out. The previous year's best system had a top 5 error rate of 26.2%. AlexNet's was 15.3. It had 60 million parameters, trained over 5 or 6 days on 2 consumer graphics cards. Almost nothing about the idea was new. The mathematics was decades old. The hardware had finally caught up. That is the real lesson of both winters. The ideas were rarely wrong. The timelines were catastrophically wrong. Every collapse had the same shape. A real result, then a promise about what it meant, then a widening gap between them. So be careful with confident timelines. Remember 3 to 8 years, and who said it. Follow for one machine truth a day.